last Friday, we have learned hyperbola graph, which is that shape. Okay, so we talk about the key features for that graph. There are two asymptotes. Okay, not necessarily on the axis or y-axis, like will be a vertical one and a horizontal one. If the asymptote is on the axis or y-axis, you still need to sketch it out. Like you still need to use your pen to draw it and then write out the equation, like x equals to something, y equals to something. And then you have like two branches of the curve, and you need to make sure where's the axis and where's the x-intercept and y-intercept. Also, we have the domain and range. We discussed the domain and range for this graph. We can see this graph can take all the x except the asymptotes. If you just go through, as I said, when you talk about the domain, I'm not sure if I have talked about this. When you talk about the domain, you just use your ruler from the left-hand side, trying to touch with the graph. If you can touch the graph, which means your x can be that value. So you can see, okay, I can touch forever that side, negative infinity. Go here. I can still make the intersection with the graph. Until here, there's no intersection with the graph. So my x can't be the x value of that point, which is x equals to 0. And then keep going a little bit right-hand side. I can still make contact with the graph. And then keep going. I can always touch a graph on the right-hand side. So the only point I can't touch is this line here. So is when x equals to 0. So that's why we have a domain R except 0. And then the range will be a horizontal line from the bottom. I can still make contact with the graph, which means I can have that y value. Keep going up, I can always make contact with the graph until this line y equals to 0. You know that's the asymptotes, there's no intersection with the graph. So your y value can't be 0. And then keep going up, you will make contact with the graph, and up, all the way here, I can always touch the graph. Therefore, my range will be R except 0. According to this, we can see the domain range will be R except, the domain will be except the x asymptotes, and the range will accept the y asymptotes. So that's the domain and range for this graph. And also the general equation we see, the general equation will be a number over a linear. Okay, a number over a linear. So a over, well, a linear. And then plus another constant. Okay, that will be the general form of hyperbola. So if anytime you see a fraction with a number on top and the linear equation at the bottom, that will be the hyperbola graph. And also last lesson, we have learned that a linear over linear, that will be a hyperbola as well. We go through the long division method. Well, this file is not the previous one. I can't open the previous one. I don't know why. The linear divide by linear, we use long division to do it. We can still make into a hyperbola form. If you don't really know how to do long division, we'll learn that in chapter 6 in detail. But like linear divide by linear is easy. It's just a number and use the number to times the dividend and then subtract it. Any questions? Yes?
So if you have equation and you don't have a linear over a linear, you have like a constant and then a linear over a linear. And
a constant over linear.
No, like.
Give me an example.
Like 2 over 2x plus 1.
Yeah.
So, and then you want to find the x-intercept to make y.
Yeah, you still make y equals to 0.
But then how would you
like for example, is y equals to 2 over 2x plus 1, for example, is that.
Yeah.
This is a plus 0 at the back, right? Yeah. Your y asymptote is 0, which means there's no x-intercept. Okay. There's a horizontal line on the axis, which means you can't have that. Okay. Otherwise, you will like find some, like if there's no asymptotes, you can definitely solve for it. If that's a 1, if I make y equals to 0, I can solve for it. Yeah. Okay, so today we are going to learn something really similar to hyperbola, which called truncus. It's very, very similar. It's very, very similar to a hyperbola graph. Okay, so you can see we still have two asymptotes, x equals to 0 and y equals to 0, horizontal one and vertical one. And instead of like like 2 branch for the hyperbola will be top and bottom, or this way, the other way around. But for this one is 2 on the top, okay, 2 on the top, exactly the same. They have exactly the same shape, but they got slightly different equation. So the equation will be this. A over x minus h squared plus k. Okay, just be aware, the bottom must be something squared. Well, it can't be 2 over x squared plus 1. It can't be that. Can you see the difference? You can plus the 1 with the x and then square that. You can't square it first and then plus the 1. Say it must be in the perfect square form. Okay, the bottom must be in the perfect square form. It can't be squared and then plus 1. That's not a truncus graph. Even though the bottom is still a quadratic. Okay, it's still a quadratic. Well, like the previous one, it's a linear. Okay, so it's a hyperbola. But quadratic got so many forms. They got x-intercept form, they got turning point form, they got the expanding form. That's the expanding form. It's not going to be a truncus. To be a truncus, the bottom must be the turning point, like the completing square form. It can't be the turning point form. You can't plus another constant there. So it must look like this. It must look like this. Okay. So if you have this form, we can consider about this graph. We still have x asymptotes and y asymptotes here, and 2 graphs on the top. Okay, go like this way. So the domain is still r except 0, just that graph. There's no 0. Okay, but the y range will be everything positive, r plus. You can't get 0. 0 is asymptotes, but start from 0, you can make contact with the graph. So I would say is 0 not including to infinity or r plus. Okay, they are equivalent. I can say that's 0, like start from 0 but not taking 0, and then everything above 0. So it can be 0 to infinity or r plus for that equation. Let's have a look at how to sketch this graph. First, we need to find asymptotes. Well, the general form is a over x minus h squared plus k. Well, sometimes there might be what is called coefficient. There might be a coefficient in front of x. Okay, there might be a coefficient in front of x. For example, 2x minus 1 squared. That's still a quadratic. Okay, that's still a complete perfect square form. When I mentioned this coefficient, just one thing, I go back a little bit. We can also have a coefficient here, but that must be a positive coefficient. That must be a positive coefficient. And then we look at the a value. Well, a is positive, we have the first and third quadrant. If a is negative, we have second and fourth quadrant. Well, if that coefficient is not positive, if it's negative, I can't really look at a by that way to decide which 2 quadrant it will be. So we first of all need to make sure the x is positive and then look at the a value. It's just nothing to do with the truncus. It's just like I suddenly remember I need to emphasize that. If we think about this truncus graph, I will let you know that for truncus graph, the coefficient can be positive or negative. Well, positive is fine, negative is fine. Why both fine? Think about there's a negative, and you square it, it still becomes the positive. That's always the positive. Well, with the negative or without the negative, that will be the same. It only will affect the x asymptotes. It's not going to affect the shape of the graph. So you don't need to really make that into a positive number. Yes?
You have a negative for
you can, but I will put the negative on top.
Oh.
If it's outside the bracket, I will put that on top. Like then that'll become a negative a value. Okay, so first step will be y equals to k will be the horizontal asymptotes without doubt. y equals k, like you don't need to look at any other thing. That will be the horizontal asymptotes. Second one will be solve denominator equals to 0, same as hyperbola. Solve denominator equals to 0, you get vertical asymptotes. Because you have x equals to something, that's your vertical asymptotes. Why I need to solve that equals to 0? According to implied domain, denominator can't be 0. I will look at which value can make my denominator become 0, and then that will become the asymptotes. Okay, the value you can't take is the asymptotes. The value you can't take, that will become the asymptotes. If there's a single value you can't take, that value will become the asymptotes. So that's the reason behind why I'm trying to solve denominator equals to 0. If you can connect the implied domain together with that, it will be much easier to understand. Okay, number 3 is look a value. You look at a value. You have 2 types. If a positive, you have that. Okay, above the axis as x asymptotes. If a is negative, you will have the bottom 2. Okay, reflected down, you have the bottom 2. It's very similar to the hyperbola graph. Well, if it's positive first third, and if it's negative second fourth. So that's the graph, how the graph looks like. And number 4 is find x, y intercept if necessary, if possible. Well, it's impossible to find x, y intercept for this graph. There's no x-intercept graph, no y-intercept, no x-intercept. We can see it already from the graph. So we can think about the shape and then decide, do I have x, y intercept? If I have x, y intercept, I will solve for x, y intercept. Okay, let's have a look. This example here. Okay. Sketch the following graphs. Label all x-axis intercepts with their coordinates and label each asymptote with its equations. Okay, fx equals to 1 over x plus 2 squared minus 3. So y equals to minus 3 must be 1 asymptote. X plus 2 squared equals to 0. X equals to negative 2 will be the other asymptotes. It's already in the perfect standard form. Nothing wrong, like very clear. So very clear graph. Okay, x equals to negative 2. So x equals to negative 2 and y equals to negative 3. Well, my graph is a little bit small to the left-hand side. But we have a 1 on top. We have a 1 on top. I'll roughly sketch the shape. If 1 is a positive number, we'll have two graphs above the asymptotes. We'll have this shape and this shape. Okay, do not like sketch it yet. We can see we have two x-intercept and one y-intercept, right? Roughly, just by sketching it. So I need to find the xy-intercept first and then sketch on it. When x equals to 0, when x equals to 0, my f0 equals to 1 over 0 plus 2 is 2. 2 squared is 4. A quarter minus 3. Well, 3 is 12 on 4. So f0 equals to negative 11 over 4. So it's almost negative 3. So it's almost negative 3. So it's about here. Well, I will miss the left hand side of the graph. And when fx equals to 0, which means when y equals to 0, 1 over x plus 2 squared will equals to 3. Well, you want to solve y equals to 0. That must be 3. So x plus 2 squared, 3x plus 2 squared equals to 1. X plus 2 squared equals to 1 over 3. X plus 2 equals to plus minus square root 1 over 3. X equals to plus minus square root 1 over 3 minus 2. And I need to rationalize that. That is plus minus root 3 over 3 minus 2. Top bottom times the same number. You times 3 on both top and bottom. Okay, times 3 on both top and bottom. So you can see it's negative 2 plus root 3 over 3 and negative 2 minus root 3 over 3. Those two asymptotes must be x-intercept must be symmetrical x-intercept. It's from negative 2 you add root 3 over 3 and you minus root 3 over 3. They are symmetrical points. So let's say the point is those 2 points. Well, roughly is here. Roughly is here. So the shape of the graph must be this. I can't finish the other side. I don't have enough space. But like remember parallel and longer asymptotes. Like asymptotes must be longer than the graph, and the graph in the end must be parallel to the asymptotes and close enough to the asymptotes. This point is minus 2 plus root 3 over 3 comma 0. This point is 0, negative 11 over 4, and that point is negative 2 minus root 3 over 3 comma 0. And then we need to think about the domain and range. What's the domain? Yeah, all real numbers except -2. And what's the range? It can't be all real numbers. I don't have graph at the bottom. -3 to infinity, but inclusive or not inclusive? No, round bracket for both ends. I can't get -3. It's all the graph is above -3. So same, you can try to touch with the graph. The first point you can about to touch it is at the point -3, but you're not touching yet. If you move a little bit up, you will touch the graph. So that's -3 to infinity. Okay, let's have a look at the next one. Okay, I don't really like the form for the next one because there's a 2 outside the bracket. Well, if it's a plus, then it's definitely not working. But if it's a times, I can try to rearrange this equation a little bit and get into the right form. So what I can do is make y equals to -1 over 2 bracket x plus 1 squared plus 2. I don't like the 2. I want to get it out from the denominator. So I will say y equals to -1 over 2 over x plus 1 squared plus 2. I will divide 2 on both top and bottom. Or I can say I will times a half on both top and bottom. If you time the same number on the same fraction, you will have the same size of that fraction. So it's not going to change the fraction. So just times a half on top and bottom. Okay, that's what I'm doing, times a half on both top and bottom. So you get -1/2 on the numerator. Can I stop talking, please, girls? So that's the equation, standard form equation we will have. And then we can start to look at the xy asymptotes. So the asymptotes must be y equals to 2 and x equals to -1. Well, I don't need to solve. I can easily see it because x plus 1 equals to 0. X must be -1. So x equals to -1 will be the asymptotes. Okay, when we have those two asymptotes, we can sketch the graph. That line is y equals to 2. That one is x equals to -1. And the top number is a negative number. It's a negative number. So therefore I'll have the bottom graph. Okay, not the top graph, I will have the bottom graph. So it's not outside. Like this. I can still find 2x intercept and 1y intercept. I will still work out that first. So I will say when x equals to 0, y equals to 2 minus 1 over 2. I use the original equation because at sub x equals to 0, the bottom is 2. So 2 minus 1 over 2. That will be 3 over 2. So 1.5. Shouldn't write it that way. Y equals to 3 over 2. 0, 3 over 2. So can you see my graph is actually wrong? It shouldn't go that way. It actually should go this way. It's more stretched this way. Because what I have is a negative y-intercept, but I should have a positive y-intercept. So this is helping us to make sure where the graph should exactly be. So that's why I said don't sketch it yet, like until you find out the value. So the point should be here, 1.5. 0, 3 over 2. And then I'll solve when y equals to 0. 2 must be equals to 1 over 2x plus 1 squared. Okay, 2 minus something equals to 0, so 2 must be the same as that number. And then 4x plus 1 squared equals to 1. X plus 1 squared should equals to a quarter. Yes. Where's the... Which one should be minus 2? No? Which part are you talking about? Yes? Where? Which line? This line? Or when y equals to 0? That's equals to 0, right? Move this to that side. That's the same. 2 equals 2. Times denominator. Everything on the denominator times to that side. When I solve equations, I don't like denominator. I will always times the denominator on both sides of the equation and try to get rid of it. So x plus 1 will be plus minus a half. Okay, square root a quarter is a half. So plus minus, okay, never forget the plus minus when you take the square root. So x equals to a half minus 1 or minus a half minus 1. So x will be minus a half or x will be minus 3 over 2. So minus a half is here. Minus 3 over 2 is here. You're trying to draw it like symmetrically. Okay, I was trying to draw it like to symmetrical about the x equals to minus 1. Minus 3 over 2 comma 0, and that is minus a half comma 0. Graph needs to be parallel and get close enough to the asymptotes. Okay, what's the domain for this graph? Real numbers except -1. And range is 2 exclusive. Thank you. -infinity to 2 exclusive. So the domain and range for a hyperbola function will be R except something, R except something. But the domain and range for the truncus function, domain will be R except the x in asymptotes, but the range will either be above the x asymptotes or below the x asymptotes. So it's either -infinity to asymptotes or asymptotes to infinity. So you only have these two options. It depends on the shape of the graph, above or below the asymptotes. Okay, that's the second one. The second one shows you that if there's a number in front of the square, like what we can do, we can just put it on the top. It's not going to change the shape of the graph, and it's not going to change the type of the graph. Okay, we can have a look at the next one. Well, next one looks quite complex, but I will rearrange it first. Okay, have a look at this one. Well, I just swapped the order. I haven't done anything. I put a negative sign onto the top, -1 over -2x plus 3, put into the linear form, squared, and then +1. Nothing wrong, we have a coefficient, and we don't really care about whether the coefficient is positive or negative, as long as it's not outside the bracket. If it's happened within the bracket, that's okay. So that's what we'll have. Then we'll look for the asymptotes. Asymptotes will be y equals to 1. And the other one will be -2x plus 3 equals to 0. 2x equals to 3. And x equals to 3 over 2. That's the xy asymptotes. Okay, that's the xy asymptotes. As I said, you just solve denominator equals to 0. So the thing in the bracket equals to 0, then everything equals to 0. So x equals to 3 over 2 and y equals to 1. Well, because it's a negative on top, I'll have bottom graph. I'll have those two graphs. I don't know where it will pass through yet, so some shape like that. There will be xy intercept. Okay, there will be xy intercept. So again, I'll solve xy intercept. When x equals to 0, y equals to 1 minus 1 over 9. Y equals to 8 over 9. So 0, 8 over 9. 0, 8 over 9 is a value really close to the x asymptotes already. So the red dot is actually there. Can you see that? It's actually there. We have a positive y-intercept instead of a negative one. So it's not very accurate for my graph. That's 0.8/9. And we solve when y equals to 0. 1 equals to 1/3 minus 2x squared. This must be the same. So 3 minus 2x squared must be 1. So times the denominator to that side. 3 minus 2x equals to plus minus 1. Okay, plus minus 1. You can have 2x intercept. How we can find 2x intercept? That must be a plus minus case. So 3 minus 2x equals to 1. 3 minus 2x equals to minus 1. Okay, solve them separately. 2x equals to 2. X equals to 1. 2x equals to 4. X equals to 2. Move 2x to the right hand side, move the constant to the left hand side. So we have 1, 0 and 2, 0. It's not those two parts of the graph. One, 0 and 2, 0. Yep, that's the shape of the graph. This side is not really nice. Okay, that's better. Okay, the third case shows you, well, if there's a coefficient, what we should do. Okay, if there's a coefficient, what we should do. If the coefficient is inside, what we should do, well, we ignore it. If the coefficient is outside, we're trying to put it onto the top. Like, that's what we'll do. So this graph got a domain. Okay, let's talk about the domain. What's the domain? All real except 3/2. And the range is to 1, exclusive. Yeah. Okay, so that's the truncus graph. That's pretty much the same with your hyperbola graph. That will be your only case. Learn those two graphs. We are not going to repeat that in year 12. Okay, you just use for it. That's it. And the linear over linear case, we use that quite a lot in year 12. So you need to remember that. Okay, linear over linear is a hyperbola. That's the only time you learn those two graphs, and we are not going to repeat in year 12. So you need to really learn this topic well. And also the other three graphs we'll learn later. So we will use the graph only in year 12. Okay, so the rest of time you can do your homework. The chapter 4a, you should complete that now, and then 4b as well. I'm not going to check your 4a only today. I'm going to check it all together next week. So you should be able to finish all of chapter 4, okay, up to Monday. Like, we'll finish everything for chapter 4. So you need to do your homework now.